Okay, today we're going to look at the greatest common factor. We'll do some story problems and we'll solve these questions in two different ways. Greatest common factor. Let's start off with a joke. Why did the golfer change his pants? He got a hole in one. It's time for our daily review. Write this expression in another way using the commutative property. Pause the video and try this on your own. Alright, remember the commutative property says you can write things in more than one way and you still get the same result. So we have 5 plus 9 here. I could write this as 9 plus 5. And it still equals 14. The same thing works for multiplication. So if an example I had 2 times 3, that's the same thing as 3 times 2. That's it for our daily review. As we mentioned earlier, our learning goal is greatest common factor. So, what is the definition of a greatest common factor? Well, the factor that is shared by two or more numbers, the GCF. Well, in order to understand, you got to understand a couple other things too. So, factors are the numbers we multiply together to get another number. So, example, let's take that 2 times 3 example again. It equals 6. Well, what are the factors? The factors are the numbers that are multiplied, 2 and 3. Okay, so are there other factors of 6, 2, and 3? Well, there could be 6 times and 1 are also factors of 6. Before we continue, you also have to understand what a prime number is. I have a list of a whole bunch of prime numbers right here. You also have to understand what a composite number is. So for example, if we take 6, can we break this down further into 2 other numbers? If we can, then it is composite, okay, other than 1 in itself. Okay, so let's continue. Okay, so we got a list of questions here. I won't go through all of these, but I'll go through a couple. Let's start with the GCF of 6 and 8. Remember, GCF is the greatest factor shared by 2 or more numbers. So we're going to solve this in 2 ways. I'm going to draw like an L here, like that, for 6 and 8. Now I'm going to look for a common number, a common factor of 6 and 8. Okay, so I can factor a 2. That's a common factor. 2 times 1 equals 6, 3. Or 6 divided by 2 equals 3. 8 divided by 2 equals 4. So my greatest common factor is going to be the 2 on the outside. Let's try it another way. Okay, so I have 6 and 8. I'm going to do something called a factor tree. And I'll look for 2 factors of 6 and 8. 2 factors of 6 and 8. Now I'm going to continue because I have prime numbers here. Hey, would it matter if I wrote this as 3 times 2? No, because if you remember back to that example with the commutative property, the order doesn't matter. Now, since I have a composite number here, I can break it down even further. Okay, so now I'm going to list my factors, 2 and 3, and I also have 2 times 2 times 2. I'm going to circle my common factors here, and my only ones I have then is 2. Just like in this example, my greatest common factor is 2. Okay, next question. Greatest common factor of 30 and 45. What's the common factor of 30 and 45? Okay, so now 30 divided by 3 is 10. 45 divided by 3 is 15. Okay, so now I am going to continue my factoring. 10 divided by what? I could divide both of these by 5. This is 2 and this is 3. Unlike the last question, I have 2 numbers on the side. I have to multiply to get my greatest common factor, which is 15. Now let's do it another way. 30 and 45. 2 factors of 30. 6 and 5. Okay, so I'm going to look for prime numbers on my list here because I don't have those memorized. And, 5 is a prime. But 6 needs to be broken down. What is that called when it's not a prime number? It's the other one? Yeah, it's a composite number. Okay, so now I've got it into all primes. Now, I'm going to break this down further. 9 is a composite number. and I have 3 times 3 times 5. I will list my numbers, and then I'll list the factors. It's important to put these in order. Okay, so 3, 3, and 5. I'm going to circle my 3's and my 5 here. I do 3 times 5, and my greatest common factor, like in the last question, is also 15. There we go. Okay, let's continue. We have 16 and 24. So we want to find the greatest common factor of 16 and 24. Remember, the greatest common factor is the factor shared by 2 or more numbers. Okay, so what 2 numbers multiply together to get 16? Did you say 8 and 2? You could have. You could have also said 4 and 4. Let's continue with 8 and 2. 2 is a prime number, but 8 is a composite number. Remember, a composite number is we can make it by multiplying other numbers. It's called a composite number. So I could break this down even further, essentially, into 4 and 2. I can keep going into 2 and 2. And I'm going to bring down all my 2's. Before I write my list, I'm going to do the same thing for 24. I'll pick 8 and 3. Again, doesn't matter whether it's 8 and 3 or 3 and 8. No, because think back to our vocabulary preview question where we had the commutative property. So we can now break this down further, and we have a composite number here, so we'll do 2 times 2 times 2 times 3. Now I'm going to list my factors of 16 and 24. 2 times 2 times 2. Hi. And then I'm going to list my factors of 24. Circle my factors, just like on the last question, and then I'm going to multiply those together. The greatest common factor is 8. Alright, that's one way. So another way to do this is to draw an L and think of a common factor of 16 and 24. Well, how about 4? 16 divided by 4 is 4, and 24 divided by 4 is 6. I can keep going, so I'll do that. Divide 4 and 6 by 2, we get 2. 6 divided by 2 is 3. Now, like the last question, I've got numbers on the side, so I'll have to multiply these 2 numbers here. And 4 times 2 is 8. So my greatest common factor of 16 and 24 is also 8. Alright, so the reason why you all came today is a story problem. Now that you've established a good understanding of how to do the procedure for greatest common factor, let's take a look at a story problem. Pause the video and try this on your own, and then we're going to look at the solutions. Okay, let's go through the question. Here it says, what is the greatest common number of columns in the 2 bands arranged? Also, how many band numbers will be in each column? So we've got 2 numbers here, and we have 56 and 96. So I'm just going to do this one in one way, okay? And you can do the same as well. So 56 and 96, what's the greatest common factor of 56 and 96? 8. 56 divided by 8 is 7, and 96 divided by 8 is 12. So my greatest common factor is 8. But the question wants to know how many band members will there be in each column. So we answered the first question, and now we have to answer the second one. So I'll have to take 56 and divide that by 8 for each column. Then I'll have to do the same thing for 96 and divide that by 8. And that equals 12. So then what I'll do is I'll add together the 2 columns, or sorry, the 2 band members here, and they end up with 19. So how many band members will be in each column? It'll be 19 total. Today you learned how to apply the greatest common factors. Thanks for tuning in.